Okay. All right. So I think we're live, so we can get started. So welcome everyone to the Our Ladies Dallas webinar series. My name is Sadika Watson. I am the current organizer of Our Ladies Dallas. I work as a data scientist, and I've been working with the ladies in our group to learn more about R, learn more about different career opportunities, and we've been stretching ourselves in lots of different ways. Just a quick clarification of what I just said. So we in Our Ladies Global aim to support the use of R for all persons who either identify as women or non-binary. So if you refer to yourself as they or them, she, whatever, anything, we definitely agree that that the community should exist to support persons of women or non-binary genders. So we definitely welcome you. We welcome people who identify as men. We welcome everyone to join the space. So with that, I would like to first of all just before we get too far. Um, so I'm here in Dallas, and so of course because of COVID, because we're doing everything over the internet, we've been blessed to have not only speakers from all over, but also audience members from different places. So if you wouldn't mind in the chat, could you just kind of let us know where you're writing in from? Or where you're, I was gonna say where you're calling from, like this is a radio show, where you are joining us from. So maybe your city and state if you're in the United States, give your country if you're outside of the US. We've got already someone from Lima, Peru, Edmonton, AB, Canada, Denton, Texas, our speakers located. So connections there, Austin, Dallas. I'm also in Dallas in the Garlandish area. So yeah, so this is a good group. Definitely, we've seen people from the Middle East. We've seen people from different parts of Africa, Mexico, India. One of our speakers was from India in one of our previous sessions. So yeah, we're definitely welcoming everyone. So yeah, I'm happy that you decided to join us this evening. So what I'd like to do first, before we get into introducing our speaker, is I'd like to share my screen for a minute and apologize for the person cutting grass in the background. Sorry if you hear that. But I'll share my screen and let's see if you can see that. Okay. Yep. So what I'm sharing is the Our Ladies Dallas meetup page, which I'm sure you found at some point because you were able to RSVP and get all the login information for the meeting. But what this also gives you is information about the different events that we have coming up. So of course we have tonight's speaker, Danica Slavish, who I'll introduce in a minute. We have a few additional speakers, notice in June through the end of July, actually. So Dr. Janani Ravi will be joining us from Michigan. Prathipa Jaga, and I apologize now, I don't remember where she'll be joining us from, and then Dr. Chase Smith as well. Yeah, one of our speakers is from a super big company, so I'm kind of really excited to introduce some of the different concepts that they will introduce, and also yeah, just introduce you all, and we're going to have a great time learning about so many different things. So what I would like to do is to point out the fact that notice our speaker series is going through July 28th. I'm sure some of our Dallas people are wondering, okay, when are we going to go back into in-person events? The short answer is I don't know. I think what I'll probably end up doing is setting up a poll at some point to find out whether the members are feeling comfortable attending meetup events. We were hosting events in Plano at the Improving space. I don't know if you guys have been to that space before. They host a lot of tech meetup events, but we really like that space, and so I need to check in with them to see if they're available or to find out if some other spaces are available. But I also need to gauge interest. So let's reconnect and yeah, just kind of keep an eye out for that poll that will be coming up pretty soon. I'd also like to point out that our speakers, so the speakers that I have put on our agenda so far have been invited by me because I found them and I, sent them messages and said, hey, you sound amazing. Could you please come and speak to our group? So, and they graciously accepted our invitation. But I'm also looking for people to identify themselves as speakers. So if you feel like there's something that you'd like to share, maybe you're doing something cool in R, maybe you've got an R package that you created, or you're using an R package in, or a collection of packages in an amazing way, or you're using shiny dashboards. It could be a personal project. It could be something you're doing for work. Anything that you feel comfortable sharing. It could involve slides. It could be something that doesn't have any slides at all. Could be a full hour, could be 5 minutes, 10 minutes, so just kind of let me know what you're interested in. And yeah, we can get that set up. So I definitely want this to be accessible to everyone here. So yeah, please let me know if you're interested. And I'll probably put my contact information and also the Our Ladies Dallas contact information in the chat as well after we get started. So with that, I'll go ahead and introduce our speaker. And then, yeah, we will turn it over and learn some really cool stuff. Okay, so Dr. Danica Slavish is an assistant professor of psychology at the University of North Texas, so here in the Dallas area. Danica's research focuses on how sleep problems and stressful life experiences interact to predict health outcomes across time. Her research team uses a variety of statistical techniques for analyzing longitudinal data in R, including multi-level modeling, time-varying effect modeling, network analyses, and Bayesian analyses. Danica currently teaches courses in health psychology, advanced stats, and research methods. So, and before joining UNT, Danica completed her Ph.D. in biobehavioral health at Penn State, where she was a National Science Foundation graduate research fellow, and she holds an undergraduate degree in psychology from Beloit College in Beloit, Wisconsin. One other thing I want to point out, even though you're probably noticing in our speaker series that we have a lot of doctors or people who identify as doctor in their in the speaker lineup. You don't have to be a doctor to be a speaker. So please reach out to me if you're new to R, if you've been using R for a long time, you're kind of in the middle. Please let me know, and I would love to help you to share your ideas with the world. So with that, I will turn this over to Danica, and yeah, we'll learn more about her topic.
Thank you so much, Sadiqa. Before I get started, I'm going to just put a link to the slides. So hopefully you all can access the R Markdown file if you kind of want to follow along or check it out later. So yeah, let me go ahead and share my screen and we can go ahead and get started.
And if you have questions for our speaker, please post them in the chat.
Yeah, feel free to interrupt me as we go along if you have questions along the way. Is everyone able to see my screen okay?
Yep.
I see your screen.
Okay, awesome, perfect. Okay, well, thank you so much for having me here. I'm really excited. I'm kind of a new R user, as I told Sadiqa, so I'm really excited to have the opportunity to connect with people who probably know a lot more than I do. So I'm hoping I can learn something from you all as well. So today I am going to be talking about a technique that I've started using more frequently in my own work. And this is a technique called latent profile analysis. It's frequently used in my discipline of psychology, but hopefully you can kind of see the applications maybe to some of the work that you all do as well. All right. So I'm not going to go over kind of my background. Thank you, Sadiqa, for the great introduction. I will just say, you know, I'm kind of a health psychologist by training. So a lot of the examples that I'll be giving today will be focused on some of the work that we do. And actually see Heather, one of my collaborators, is here today. So we've been working on a project that I'll highlight in the slides later. So yeah, in our lab, we focus on sleep and health outcomes broadly. So we're interested in complex behaviors like sleep and how does that predict various health outcomes across time. So I learned SAS, actually learned SAS in grad school and transitioned to R in the last few years. I kind of taught myself how to use R as a postdoc. So I'm definitely still a novice, still kind of soaking up knowledge, definitely don't feel super comfortable in R, but I'm excited to kind of find this community and hopefully learn from you all. All right, so today I'm going to be focusing on latent profile analysis. So this is going to be a relatively focused talk. I'll try to keep it relatively short. I'll walk through kind of an intro of this technique and then show you an example. And you're welcome to use any of the code that I posted in the link. All right, so latent profile analysis is basically a statistical technique for data reduction. So you might notice some similarities to things like k-means clustering, if you've used that before, or factor analysis. Basically, what we're trying to do with latent profile analysis is take a set of variables and identify hidden clusters or patterns of responses to these variables. So we can essentially group people into different categories based on multiple variables that they provide responses to. And the important thing about latent profile analysis is that basically the people in these groups are distinct from one another, but the people within the groups are similar. So we create these profiles or groups of individuals based on their responses to a set of variables, and everyone is classified into one of these groups and only one of these groups. So latent profiles are what we call mutually exclusive and exhaustive. So you only get assigned to one profile, and everyone in the data sets gets assigned to a particular profile. Now I'm going to use the word class and profile kind of interchangeably here. So basically, when I say class or profile, it just means those groups that we're creating based on people's responses. Okay. All right, so I kind of like this quote here. Basically, LPA is a form of mixture modeling. I'm not sure if any of you use that technique in your own work, but this quote here I think sums it up nicely. So mixture modeling is the art of unscrambling eggs. It recovers hidden groups from observed data. So we take a data set, we take variables in that data set and try to identify kind of these hidden groups based on similar responses to a set of variables. All right, and this is really helpful when we've got like complex patterns of behavior or sort of a diverse group of individuals. And we're trying to understand kind of which individuals maybe are more similar to each other, and do those group memberships predict some sort of outcome. All right, so I use this in my work because, like I said, I study sleep, which is a pretty complex health behavior. There's multiple facets of sleep, which I'll talk about more in a second. And you know, when we're studying sleep, we have to consider other behaviors that people are engaging in. So for example, maybe a person is able to get 8 hours of sleep every night, but they're also engaging in other health behaviors like excessive alcohol use or low levels of physical activity or a poor diet, right? And we want to see how all of those variables cluster together. Are there certain patterns of people's health behaviors that we can identify people based on, and do those group memberships predict some sort of outcome? That's essentially what we're doing with latent profile analysis. So we're taking a bunch of variables and then we're classifying people based on their patterns or responses to multiple variables, and then using that class or profile membership to predict some sort of distal outcome. All right, so like, for example, another thing you could think about is like, this is also used frequently in like the substance use and alcohol use literature. So for example, you might see that there are like 3 patterns of alcohol usage: people who are binge drinkers, people who drink moderately, and people who never drink alcohol. And we might want to see which of those groups has the best health outcomes. Or are men or women more likely to be in one of these alcohol groups? Or so you can look and see what predicts group membership, and then does group membership also predict some sort of other variable? Okay, one other example, and this is a really cool kind of body of research from someone who does work on PTSD or post-traumatic stress disorder after natural disasters. So this researcher used latent profile analyses to identify these 4 patterns of responses among individuals after they're exposed to some sort of event like 9/11 or some natural disaster. And he has identified across multiple studies, he's found this pattern of these 4 kind of responses after people are exposed to this traumatic event. So it seems like there are some people, which he calls this chronic or chronicity pattern, of people who got really severe disruptions in psychological functioning. And that stays high, even a few years after they're exposed to that disaster. There's another group of individuals, which he calls this recovery group here, that seem to have some disruptions in functioning right after the event, and then it kind of drops down to lower levels a few years after they're exposed to that event. And then a third group here kind of has this delayed response where they have disruptions in psychological functioning 2 years after the event occurs. And then finally, there's this resilient group who really doesn't experience much disruption at all after they're exposed to that disaster. So they've got kind of low levels of disruptions in psychological functioning across time. All right, does anyone want to take a guess here at what is the most common pattern? This is just for fun. So which group here, which profile do you think most people fall into? This has been replicated across several studies now. So do you think most people are resilient, show this kind of recovery pattern, delayed response, or chronic disruption? Let's keep an eye on the chat here. Okay, some people are saying recovery. Okay, one person said resilience, one person said delayed, recovery. Seems like most people are saying recovery, which kind of makes sense. Like that's what I would guess too, where you've got this kind of like, immediate increase in, disruptions in functioning, but then you kind of return to normal. It's actually this resilient response. So most people do not experience severe disruptions even after being exposed to a pretty severe disaster. So anyway, this is just an example to show you that, based on this data that he collected, he was able to identify these 4 patterns of responses. And this is actually called latent transition analysis, where you're looking at these patterns and how they change across time. But the same principles apply. Each person in the data sets gets characterized into one of these profiles. And then we can also see what correlates with people's profile membership. All right. So why would you be interested in using LPA? I know we all come from different disciplines. Some of you are more in kind of business side of things, but I think this kind of technique can be applied to a lot of different disciplines. And the cool thing about latent profile analysis is you get the probability, the exact probability of people being in one group versus the other, one profile versus the other. So this is superior to some other data reduction techniques that you might be familiar with, like k-means clustering, because we get those probabilities. So like I can know the exact probability, for example, of people being in each of these 4 groups. So using this tidyLPA package that I'll talk about, we can get those probabilities. So we have a little bit more confidence. Is there a probability of 0.99 that people are in this chronic group versus the resilient group? For example, we can know that exact value, which can be helpful. All right, so if we were to kind of break down, like what are the steps you need to go through if you want to run this type of model, it's relatively straightforward. Basically, first, what you need to do is select the variables that you're interested in. These are called indicator variables. So what are the variables you're going to use to build your model to determine that profile membership? So, going back to the example I was talking about earlier, you might pick like the number of alcoholic drinks someone has per week, how many hours of sleep they typically get, their diet or exercise patterns. And then we use those variables to estimate which profile people are in. So you pick the variables you want, and then you build the model, and then you examine the model fit. So let's say we test a model where we think there are going to be 3 profiles of people. We want to examine the model fit of that 3 profile solution, and then test it against an alternative model, like a 4 profile solution or a 2 profile solution. So you can know with certainty what is the best fitting model to your data. All right, so after we examine the model fit, testing a few different alternative models, then we can see which variables predict profile membership. So you might have other variables in your data set that you use to predict which class or profile a person is in. So we can use logistic regression or multinomial logistic regression to see what variables predict class membership. All right. So I'll walk through each of these steps here using an example. So like I said, I'm a sleep researcher, so sorry, all the examples are going to be about that. But basically in the sleep world, when you think about sleep, it actually consists of multiple dimensions. And so this is a model that was developed by a sleep researcher. Basically, when we think about sleep, you can think about facets like people's just kind of subjective perception of their sleep, how satisfied they are with their sleep quality. Also, how refreshed or alert do they feel after they wake up? Timing, sleep timing is also another really important facet of sleep that we're interested in. So, do you go to sleep at midnight and wake up at 6 a.m. or do you go to sleep at 7 p.m. and wake up at 3 a.m.? Are you a night owl? Are you going to sleep really late and waking up in the middle of the day, right? Each of those patterns could have different health outcomes. And then we're also interested in sleep efficiency, which is basically how long people are actually sleeping divided by how much time they spend in bed. And this is really important for insomnia, where people spend a lot of time in their bed actually not sleeping. So we look at this variable to see how well consolidated people's sleep is. And then finally, duration. So how long are you sleeping at night? All right, so these are 5 different components of sleep, and people might have different patterns depending on what variable we're looking at here. So we can kind of classify people based on these collection of different sleep dimensions. So it might be like you're getting sufficient sleep duration, you sleep 8 hours every night, but you're going to sleep at 3 a.m. and waking up at 1 p.m. All right, and that could be, you could have some very different outcome than a person who's also getting 8 hours of sleep, but going to sleep at like 11 p.m. and waking up at 6 a.m. All right, so I'm going to use these different sleep variables or dimensions to classify people into different profiles and see if that predicts differential outcomes. All right, so in this case, what I was interested in knowing is, are there different types of sleepers? So based on these 5 variables, can we classify people into different categories? And then what factors predict whether someone's in one category versus the other? So these are both questions that we can answer using latent profile analysis. All right, so I'm going to run through an example here. And this was a data set, Heather's familiar with this. We're working on a paper with this particular data set. So we collected data from 392 Dallas area nurses. As you can imagine, nurses have pretty disrupted sleep. They've got stressful jobs. They're working rotating shifts. They might work days, some days, nights, other times. So basically what we did, we collected these nurses' sleep data across 14 days. So each morning when they woke up, they completed a survey to report on their sleep the previous night. And then we just basically averaged these sleep variables across this 14-day period. All right. So the variables I'm going to talk about for this particular example are 3 different facets of sleep. So the first, this is the name of the variable here, diary_TST_mean, is people's average sleep duration in hours across those 14 days. So how many hours of sleep did nurses get on average each night? We also looked at something called circadian midpoint, and this is basically people's halfway point between when they go to sleep and when they wake up. So if I go to sleep at midnight and wake up at 6 a.m., this value would be 3 a.m. Okay, so it's basically that halfway point, and this helps us understand people's sleep timing. And then we looked at sleep efficiency, which is, like I mentioned, people's sleep duration divided by the time they spend in bed, multiplied by 100. So it basically tells us how much time do you spend in bed actually sleeping, which is important for insomnia. So these are those variables we're going to select to build our model, build our latent profile model. Okay, sometimes you'll hear these called indicator variables. It just means those variables you're using to create the profiles or classes. Okay, so if you're able to access that R Markdown file, you can go ahead and load this library here. You can install and load the library. This is a really cool package that was recently developed called tidyLPA, and it was designed specifically to run these kind of analyses. So there's a really helpful vignette online if you want to check that out for more information. All right, so we'll go ahead and load this library. And then this link here contains some data. This is real data on these nurses, just kind of a subset of the variables. So the data should be accessible here if you kind of want to follow along or test it out. So we're just going to read this CSV file in, and I'm just calling the data survey in this case here. Okay, so this is kind of the meat of the code that you would use to run these latent profile analyses. And I'll walk you through this here. So basically using, the tidyverse package, right? You can see we've got the pipes here, but basically all you're doing is telling R that to look in the data set survey, and then we're selecting those variables that I mentioned earlier. So total sleep time or sleep duration, circadian midpoint, and sleep efficiency, those three variables that we're interested in. And basically we're scaling those variables here. We're putting them all on a standardized scale. And then in this case, we're telling R, go ahead and estimate 3 profiles. So we think, based on theoretical reasons, that there might be 3 patterns of people's sleep based on these 3 variables. Okay, so you could say 2 or 4 or 5. Or you could estimate a range of profiles and see which model has the best fit, which I'll show you how to do here in a second. Just for the purposes of this example, I'm going to first start by estimating 3 profiles. So I think there's 3 patterns of responses based on these particular variables we're interested in. All right, and we're just putting this in an object that I'm calling model 3 or M3. All right, when we run this model and you print this object here, this is the information that R is going to give you. Okay, so this contains a lot of helpful statistics about how we can evaluate how well our model fits these data or these classes. All right, so first what you want to do is look at, well, first it's telling us we estimated 3 classes or 3 profiles. Then you want to look at these AIC and BIC values. All right, so in this case, lower values are better because that's telling us our model is a better fit to these data. And then you can also look at this entropy value. Higher values are better. Essentially, you want a value that's 0.8 or above. And this tells you how distinct the classes are that we estimated. Okay, so basically, did we do a good job of classifying people into one group versus another? And in a second, I'll show you the actual, you can get the actual probabilities for each person in your data set of belonging to one class versus another. This probability min and max is, it's telling you the minimum probability in each of the classes that you estimated. So you want this to be, basically you want like a high maximum probability. That's telling you again that there's a high probability that people are in one class versus another. this n, min, and max is telling you the percentage of people that are in each of the classes that you estimated. So if you've got, for example, this value here is telling us one of our classes only has 5% of our sample in it, which might be considered relatively small. Okay, and then the last value here is helpful when you're comparing models. So I'll talk more about that here in a second. All right, this information in and of itself is not really useful unless you're comparing it to an alternative model where you may have estimated like 2 or 4 classes instead of 3. All right, the really helpful thing I think is visualizing the data, because this helps you see what's going on with your classes. Okay, so what this figure here shows us is we've got our 3 sleep variables down at the bottom, and it's plotting the mean values for each of the 3 classes based on those indicator variables we selected. All right, so just looking at this, we can see there's some separation across the classes, which is good. So they're kind of like 3 distinct patterns based on these 3 sleep variables we selected. All right, so just looking at this, I know it might be a little hard to see here. So if we take a look at class 1 in red, essentially what this is telling us here is that there's one group of people who's got kind of low sleep duration, short sleep. They've got kind of average timing, and they've got poor or low sleep efficiency, meaning they're spending a lot of time in bed, not actually sleeping. So based on just looking at these values, I would classify this red group as like probable people who probably have insomnia. They've got short sleep and poor sleep efficiency. All right, if we look at this second group here, class 2, you can see they've got kind of average sleep duration. They've got really late sleep timing. This is like 2.5 standard deviations above the mean. And then they've got kind of average sleep efficiency. The fun part here is coming up with names for your different classes. So anyone want to take a stab, like what would you name this particular class of people who's got kind of average sleep duration, you know, average sleep efficiency, but then they're going to sleep really late, it looks like. Anyone want to come up with any creative names for this group?
Night owls.
Exactly, yes, that's what I named them too. They're either night owls or they're night shift working nurses. So we don't know. We don't know, but I call them night owls too.
The chat actually, someone said,
oh, okay.
I love that.
Right, exactly. Yeah, they totally could be, yeah, college students. In this particular example, because it's nurses, it's probably, I'm guessing, people who are working night shifts, but it might just be people who are staying up late, right? So it's like they've got good sleep overall, but they're just going to sleep later. So that's interesting, right? And then we've got a third group of people who's like pretty much got, you know, kind of standard, average, relatively good sleep all around. So I would call them something like good sleepers, you know, not experiencing a lot of impairment. So it seems like we've got these 3 distinct groups. So these are the names that I came up with. You know, identifying the classes is actually important, because if you can't give a name to those classes, then probably you need to estimate 1 fewer class, or, you know, your model is probably not going to work. Now, obviously, more complex models could be a better fit to the data, but is that really adding anything at a theoretical level? So I called that first group insomniacs, that second group night owls, and that third group good sleepers. So we see these kind of distinct patterns based on these 3 sleep variables that we're interested in. All right, I did mention, you know, you want to test your model against alternative models. So in this case, we can use this tidyLPA package to estimate and see what happens when we estimate 1, 2, or 3 profiles. So maybe it's you know, the 2 profile solution is a better fit to our data, or a 4 profile solution is a better fit to our data. So you can do that pretty easily in R using this code where you just do like 1:3, and it estimates 1 through 3 profiles, and then compares the solutions based on these 2 model fit indices. Now you could select other model fit indices too. All right, so when we do that, so when we check and see and look at these competing models, estimating 1, 2, or 3 profiles, R is going to give you this output. So you can see here, basically it's giving you the information on the fit indices when we test 1 class, 2 classes, or 3 classes. And I mentioned that these values, lower is better. So, looking at these data, it looks like the 3-class solution is probably the best fit, but it does depend on the specific fit index that you use. So you might want to evaluate other fit indices, or potentially like think about, do these groups make sense conceptually or theoretically? Okay, so this can be kind of tricky because, like we saw in this example, depending on which fit index you look at, it could give you different recommendations for how many profiles to estimate. So there's an article here that you can check out. Basically, you want to look for, like I mentioned, like theoretical meaning. In that previous example, it was pretty easy to see that there are like 3 distinct patterns, and they kind of make sense based on the data. You want to look at various fit indices and then look at those entropy levels. Are we distinctly estimating who's in one group versus another? And then you can also compare models using that a likelihood ratio test and see if one model is a better fit than another. Okay, so I mentioned that the cool thing about LPA analyses is that you can get the actual probabilities. So I can see, for me, what is the probability of me being in that insomniac group versus the night owl group versus the good sleeper group. So we could do that for each person in our data set. And this is really useful because, like, you might want to actually take a look at some of those raw probabilities and see how well your model is classifying people. All right, if we wanted to do that, using the tidyLPA package, we can take that object that we created to estimate the latent profiles and use this command get_data. And then you can see the exact probabilities for each person of which class or profile they've been categorized into based on those sleep variables we selected. So for example, if we look here, the first 5 people in our data set, there's almost a probability 1 that they were classified in the good sleepers group. We can see the probability is 0.99 for the first 5 people. The 6th person in our data set, there's a very high probability that they are in the insomniac group, the first class that we estimated. So the cool thing is you get the probability for each person for each class that we estimated, or each profile that we estimated. So we can be pretty certain that this person should be in class 1 and these people should be in class 3. All right, I'll just pause for a second. I know I'm kind of like whipping through this. Any questions so far?
Nothing in the chat, but yeah, feel free to jump in the chat if you have any. But I definitely have a question. I was wondering about, so just thinking about situations where you've got a lot of variables and you don't know which ones are the ones that are really important. Do you have any guidance as far as helping the algorithm figure out which ones, or is there like a variable selection routine or something like that that you do here?
Yeah, that's a great question. Yes, that's the tricky part too that I didn't really talk about. There are some recommendations for like how many variables you select. Some people say like for those indicators, you need anywhere from like 3 to 10, or some people even say 12. So in terms of number, I guess more can be better, but in terms of the actual variables, yeah, that's a great question. I think it's going to depend on kind of what you're interested in, what questions you're trying to answer. But there's some resources I have at the end, and maybe those articles probably talk a little bit more about that, because I think that's a great question. I think it's mostly driven by what you're interested in investigating, and maybe kind of what other people have found and theoretical meaning. But yeah, if you pick a bunch of variables that are, not related, it's going to be difficult to probably estimate the class membership.
Yeah.
So maybe looking at correlations too ahead of time could be helpful.
Okay.
Yeah, but that's a great question.
Okay, great. Yeah, I'll be interested to see those resources you're going to provide at the end.
Yeah.
We do have another question. Why do we have to do single imputation before scaling?
Yeah, that's a good question. This is the default option in this package. I don't know if you can change that to like multiple imputation. I can look into that. This is just kind of the default setting. I think it's just to have more confidence in the classes that we're estimating, but I can look into that. That's a great question.
And I wonder if and Vilma, if you want to chime in if I'm mischaracterizing your question, but if it is it when you say do you have to do it before? Why do you have to do it before scaling? Is there like a specific reason why?
Oh, I see. I don't think there's any. You don't have to do it before. Like you could probably move this command.
Okay.
If that's what you're asking. Let me
Oh, someone was asking if you could remove it altogether.
Oh, you can remove it? I'm not sure. Again, I think this is the default option in this code. You could try it and see if it works.
So
I think you need.
If it works with missing data or.
Yeah, I think it has to do probably with missing data. I wonder if we can remove it since we're working with averages. That's a good question. My sense is you need that piece of the code to get it to run, but you could try it and see. And I don't know if there are other options like multiple imputation.
Okay.
Yeah, that's a great question.
Thanks.
Yeah, let me know if you run it and you see what happens. Another question. Okay.
No more questions.
Yeah, these are great. And again, this is like, yeah, I'm kind of new to this package, and there is pretty extensive documentation on it in the vignette. So if you check, there's a link at the end of the slides that has more information on that vignette that you can check out that explains some of these options. Yeah, okay, so after we get those probabilities, I think it's helpful to actually look at the data here, like look at some of the observations in your data set and see those probabilities, so you can kind of just eyeball, is the model doing a good job of classifying people into one group or the other? And then the final step in this latent profile model process is seeing what predicts group membership or profile membership. So what we can do now is examine other variables in our data set, maybe demographic variables, anything else that you're interested in, and see what does a good job of predicting if someone is an insomniac versus a night owl, or a night owl versus a good sleeper. So if you want, you can just kind of take the information that we estimated from the model and add it to your original data set. So that's what I'm doing here. I'm just taking the class. So, are they in class 1, 2, or 3? And then the probability, those raw probabilities of being in each of the classes, and adding that or appending it to the original data set, so that now we can see what predicts class membership. So I'm just combining that information we calculated from the model and adding it to the original data set here. Okay, so the final step then is now going back into our data set, selecting which variables we want to see predicts if someone is in class 1 versus class 2, or 2 versus 3. So this is kind of getting back to your question, Sadika. This one might be like based on what you're interested in as a researcher. Do you think there are, for example, demographic factors like age? Do you think older people might have a higher probability of being in one group versus another? So you can examine, using logistic regression, multinomial logistic regression, what variables predict whether someone is in one profile versus another. So I just use some sample variables here. So I'm looking at like people's age, gender, their stress levels, their depression symptoms. And I want to see if those variables predict class membership or profile membership. So that's what we're doing here. And because we've got 3 classes, we're using a multinomial logistic regression instead of a regular logistic regression. Okay, and then we're just running the model and putting it in this object. When you get the estimates for this model, I didn't transform these into odds ratios, but if you just look at the estimates and like the p-values, you can see what statistically significantly predicts class membership. So in this case, the first group, which is people with insomnia, is our reference group. So basically, if you look here at like the p-values, you can see the estimates here are telling us that people who are older have higher odds of being, I'm sorry, people who are older have lower odds of being a night owl, which was our second group. Our third group was good sleepers. So people who are older also have lower odds of being in the good sleeper group compared to the insomnia group. So it depends what your reference group is here, but basically you can see what other variables predict whether someone's likely to be in one profile versus another. We also see here that higher depression scores predict lower odds of being in this third group, which is the good sleepers. So basically, people with depression, higher depression, are less likely to be a good sleeper and more likely to be someone with insomnia. So again, this is going to be based on theory, like what variables are you interested in, predicting that profile membership. All right, so we use this example here to estimate 3 profiles, and based on looking at those model fit indices, it looks like 3 profiles fit our data the best. So we found, using this example, there were 3 groups of nurses based on their these 3 sleep variables that we selected. So the 3 groups seem to be people with insomnia, people who were staying up late but had otherwise good sleep, and then people who had kind of had good sleep across the board. We also found, when we looked at predictors of class membership or profile membership, people who were older nurses had lower odds of being a night owl and lower odds of being a good sleeper. So it seems like younger people are probably the people working those night shifts or staying up later. And it seems like as people get older, they're probably more likely to be in that insomnia group versus the good sleeper group. And then, kind of not surprisingly, people with higher levels of depression are more likely to be in the insomnia group and less likely to be in the good sleeper group. So we can know what the underlying groups are and then see what factors predict the odds of being in one group versus another. Okay, so maybe you can think about some extensions of this technique to your own work. But basically, if you were to run these kind of models, first you want to build the model with those variables that you're interested in. So you select the variables that you're interested in, and then you go ahead and run a few different types of models with varying numbers of profiles. Look at the model fit of each of those models, compare the model fit, and then see what external variables predict the latent profile membership, like we did with depression, age, stress, and gender. All right, so just to kind of wrap up here, I talked about LPA specifically, but this actually has a lot of potential extensions. With LPA, we're using continuous variables, but you can use discrete or binary or categorical variables to form your classes. And in that case, it's called latent class analysis instead of latent profile analysis. And then, like I talked about with the PTSD and natural disaster example, you can actually see how people's profiles change across time. And that's called latent transition analysis. So this is kind of like an extension of what we talked about today. So yeah, in general, I think LPA is a really interesting and novel technique for identifying hidden clusters of people in your data set, especially when you're interested in complex behaviors or patterns. And this is kind of superior to some other techniques because we can actually see with, you can see the exact probability that people are classified into each of the groups that you estimate. All right, these are some of the resources I was talking about. Definitely check these out. The tidyLPA vignette is what I was talking about. This has more information about the exact options you can specify in the code. So you might want to check that out to see about that single imputation question. And then these articles here have probably more kind of theoretical background and gets into sort of the math behind this if you're interested in that. So yeah, that's all I have. This is a picture of my dogs, Olivia and Ocho. They are currently hanging out in the background. This is my Twitter handle, email, and lab website if anyone is interested. And I'm happy to take any questions that you have now. Really appreciate your attention. Thank you so much.
Great, excellent. Thank you very much, Danica. Yeah, very, very interesting. Yeah, we have a few minutes, so if you'd like to ask some questions, feel free to put those in the chat. You already answered one of my questions, which was about where people could find information about the underlying algorithms that are driving this. So that's great. I was wondering, so this one seems to be statistical based, like more based on the distributions, but I wonder if you are aware of any analogs that are tree-based, that use maybe machine learning types of algorithms to do this as well?
Yeah, that's a good question. Unfortunately, I'm a psychologist, so my math training is probably not as extensive as a lot of other people here. I am not familiar with anything off the top of my head, but check out some of these resources here. A lot of these are, I guess, not quite as recent. So I don't know if they talk at all about like applications with machine learning, but I can look into that. I'm not aware of anything off the top of my head. But yeah, really interesting question.
Yeah, it was just more my curiosity. Yeah, I think this is plenty. And I also was wondering, and maybe this is not, I mean, you could let me know if this is not a good question or if it doesn't make sense given what you understand about the algorithm. But so I noticed when you were specifying the model with the squiggle and the plus signs, so that's what we usually use for main effect modeling where there's no interactions or anything like that. So
yes.
So is there any opportunity to do any interaction type thing, or does that even make sense in this context?
Yeah, that's a great question. Yes. Yes, you can look at moderators. So like you could look at the interaction of these variables predicting class membership. Yes, that's definitely a possibility. Some people look at like multiple group models, so they see like if class membership is different among older individuals versus younger individuals. So like you can technically look at the interaction between multiple variables predicting class membership. Is that kind of what you were asking?
Yeah. And I guess I'd use that term moderators, but that totally makes sense given what I was asking.
I'm sorry. Yeah, that's a psych thing probably. It's like interaction. There's a lot of this terminology is like, it's the same word, but it's different across multiple fields. So, but yeah, interaction. Yeah, you could look at the interaction between multiple variables predicting the class membership in this multinomial model. That would definitely be a possibility.
Cool. We've got another question from John Dunn. This tidyLPA exercise is a great teaching example. Can you give us a sense of how you would use this package or similar in your lab?
Yeah, sure. So actually, Heather and I are working on a paper. Heather's here in the audience. She's a grad student at UNT. We are actually trying to publish a similar analysis here where we looked at various sleep variables and we're trying to see which factors predict class membership based on these sleep patterns. But a lot of people use this like looking at other health behavior patterns. So it's used a lot like looking at risky behaviors in adolescents, for example. So like what patterns of substance use predict future outcomes? Is it people who use cigarettes before the age of 15 and people who drink alcohol before the age of 15? Or like other like risky sexual behaviors? A lot of times people are looking at these complex health behaviors and looking at what patterns of behaviors predict some sort of outcome. So it's used a lot in the health field, I feel like. I've also seen it in like business and ecology journals too. But it seems like most frequently in like psychology, particularly health psychology. Heather, I don't know if you've seen it anywhere else. I know you do some of this work too. But I think it could also be used in like predicting patterns of consumer behavior, or I don't know, maybe someone else can think of some more exciting examples than I can, but successful interventions to get employees back to work after going off on disability leave. Right. So you could use it in an experimental or like intervention framework too. Like who is responsive to an intervention? Who is most responsive to an intervention? And how does that change across time too, potentially?
Yeah, that's a great idea as well. Okay, any other questions for our speaker? And as we're waiting for any final questions, maybe Danica, if you, while we have you here, you know, given all the success that you've had, especially looking at your bio, any advice to people who are, you know, maybe more junior to our, maybe junior in the analytics space or anything like that, to, you know, just things that helped you to grow, I guess, in your career?
Yeah, that's a great question. I feel like I am just learning so much. Like I still feel like a total novice. So I don't know. I mean, in terms of like learning R more specifically, like I feel like it's so much just trial and error. Like for me, I feel like I've just kind of fumbled my way around by like using a data set that is like of interest to me and just trying to replicate what someone else has done, which is I'm sure something like we all do. But I think that like persistence is critical, and also like not penalizing yourself for maybe like not doing something in the most efficient way and just like trying to keep keep at it, even if it's not the most elegant way to write the code or perform an analysis. And then I think like the networking part is so critical. So I'm so excited to be here and just like connect with people in other fields. That's really opened up my way of thinking. And I draw on my colleagues so much for inspiration and advice and help with coding. So just relying on your peers. Yeah, I'm sorry, I don't have anything really profound. I feel like I'm still figuring it out myself.
That is totally profound. I mean, just well, for one, I mean, there's so much to unpack in what you just said, but I think even the last point you made about networking and how important that is. I mean, I could fill an hour just telling you about how much, you know, because just think about how, so everybody thinks that when you're, you know, you get ahead by going to school and doing a good job, you know, or, you know, just, you know, everybody's going to see the great work that I'm doing, and then a job is going to appear, or promotion is going to appear, or opportunities are going to appear. But that's only piece of it. You know, the other important piece is who you know, who you can connect with, who can help you grow your skills in different areas and expose you to different things, who knows about you and can say, hey, you know, I know Danica, you know, understands LPA, you know, if you're looking for an LPA person, you could definitely reach out to her. Or, you know, just for different speaking opportunities, or, I mean, it just kind of goes on and on. But yeah, I definitely would agree that networking is very important. And also that's something I've tried to emphasize. So thank you. I promise Our Ladies Dallas, I didn't plant this comment in our speaker's response, but you kind of have to do it. You just have to learn it by doing it. You got to open up R, and you got to find some kind of project, especially a project, you know, a toy project, you know, is okay. You know, it's fine. You open the Iris data set or the Titanic data set. That's okay. But when you're actually trying to solve a problem or do something for real, where you actually are invested in the results, that's where you really have to dig in sometimes and understand, why does this single imputation thing, you know, have to happen? Or what happens if I do this? What happens if I do this other thing? So you have to really, it forces you to really learn it, I think. So yeah, I think that's a really, really critical piece of advice. So thank you for
Yeah.
sharing.
Yeah, I feel like so many of my like the opportunities that I've been able to engage in are also like kind of serendipitous. Like you make a connection with someone you don't think is gonna last, and then that ends up like leading to some opportunity that you didn't originally envision. So I think just like fostering those relationships, even if initially it doesn't seem like something that like might be long lasting, like it could lead to some opportunity that you're like you totally didn't expect. So
Absolutely. Absolutely. And someone left a comment. I appreciate the level of your presentation. I'm about 18 months into my learning, and sometimes topics like this are hard to follow. This was really accessible. Yeah, that's a really good feedback. Yeah, this was, I did realize, I did really appreciate your presentation style, that it was relatable to people at all.
thank you. Yeah.
Yeah, very good. Any other things, final thoughts maybe before we wrap? I guess not. Okay, with that, I will thank our speaker. Thank you, Danica, for taking time to put this presentation together, and for agreeing to have us record the session so that other people could join in and learn more about this later. So I'll post this after I have a chance to upload it to YouTube. I'll post the information so that you can, review the slides and the topics that we discussed. And yeah, so I think that's it. And we will look forward to seeing you all again at a future Our Ladies Dallas event. So thank everybody and have a good night.
Thanks, Sadika. Bye.
Thank you, Danica. Bye. Thanks, everyone. Bye.